Hello students, good morning to all. This is Saranya, Assistant Professor, Department of Mathematics, Dr. NGR Educational Research Institute. Today we are all going to discuss about the topic is Fourier series. Subject is Mathematics 3 for Mechanical and Civil Engineering. Subject code EBMA 22005. Now we move on the slide. These are the introduction keynotes for Fourier series. Introduction, applications, importance of Fourier series, periodic function, sine and cosine graph, Dirichlet condition, Fourier series, Euler's formulas, definition, Fourier series, problem based on 0, 2 pi, Fourier series, even or odd function, problem based on minus pi, plus pi. Introduction of Fourier series. Fourier series is a mathematical method used to represent a periodic function as a sum of sine and cosine function. It was introduced by Joseph Fourier in the early 19th century while studying the heat conduction. Applications of Fourier series is many field used in many field: signal processing, audio, radio signal, electrical engineering, heat transfer problem, vibration analysis, image compression, communication system. Importance of Fourier series. Fourier series widely used in many fields such as signal processing. Signal processing, analyzing the sound, image, and communication signal. That only you have to find out. Then electrical engineering means studying the electrical circuit waveform we have to study. Heat transfer means solving the heat conduction problems. Quantum mechanics to analyze a wave function. Now in this chapter we have to discuss about only for the signal processing Fourier series. Uh, Periodic signal. So what is periodic signal now? Continuous time, and this two types of times. One is continuous time, another one is a discrete times. Continuous time Fourier series and discrete time Fourier series. Non-periodic signal is also always a continuous time Fourier transform, discrete time Fourier transform. Fourier series and Fourier transform you have to analyzing purpose, and Laplace transform and Z transform only designing purpose. In this unit, we have to study about only the Fourier series analyzing purpose. Fourier series. Periodic function occurs frequently in engineering problem. Such a periodic function are often too complicated. Therefore, it is a describer to represent these in terms of the simple periodic functions of sine and cosine. Development of the given periodic function into a series sines and cosines was studied by French physicist and mathematician Joseph Fourier, 1768 to 1830 years are there. The series of sines and cosine was named after him. A function f of x, a periodic function, a function f of x is said to be a periodic if and only if f of x plus L equal to f of x is true for some value of L for all value of x, the smallest value of L for which the equation is true for every value of x will be called the periodic function. A graph of a periodic function f of x that has period L, capital L, exhibit the same pattern every L units along the x-axis, so that f of x plus L is equal to f of x for every values of x. If we know that what the function look like over the one complete period, we can thus sketch the graph of the function over a wider interval of x that may contain the many periods. For example, a sin x, cos x are a periodic with period 2 pi. Tan x has period of pi. This is a sin x. Sin x, it starts from only in a 0. This is like this, a sine curve, and then sine signal processing, sine is odd term, and then this is a cos term. Cos 0 value will become, it start from 0 only. This is a sinusoidal curve, and this is a cosine curve. So sine curve start from the intersect on zero line only, and cos curve is starting from one itself. One. Now periodic function. Now move on the periodic function. A periodic function f of x is said to be a period function if f of x plus t equal to f of x, where t is a positive constant for all x, which is also called period. For example, f of x plus 2 pi equal to sine x plus 2 pi, you can written as sine x. So f of x plus 4 pi equal to sine x, sine of x plus 4 pi also written as a sine x. The period t, capital T, which is called it as a 2 pi, that is greater than 0. Now we have to very important, with the help of the Dirichlet condition, we have to solving the problems. It's very most famous and in condition is important role in this unit. A Dirichlet condition. Basic is Dirichlet condition. With the help of the Dirichlet condition, we can solve the problems. Only we can solving the problem. F of x is a single value. F of x is a single value and finite in c comma c plus 2 pi. Second condition is f of x is continuous or piecewise continuous with a finite number of finite discontinuity in interval c comma c plus 2 pi. Third condition is f of x is a finite number of maxima and minima c comma c plus 2 pi. F of x or to f of x only a single valued and finite value in the interval of c comma c plus 2 pi. This is continuous and piecewise continuous. Piecewise continuous means like that you can draw that the piecewise continuous. So we can draw one line. So this is a line for it with breaking. So some certain stage it will be in a continuous, and suddenly some break we have to continuous in this path like that. This is a piecewise continuous. It start from like that now. For like the graph like this. This is a graph now. Some stage it is a continuous, again that stage will become again some in between we have you have in a gap, that is not piecewise continuous. So it start from the graph like that, and this is a piecewise continuous. Continuous means the curve like that without destruction, any destruction, and this is a continuous. Piecewise continuous means like this. We can start this line, and we can, or some of the part will be continuous, again some little bit break, again it will be in a continuous. This is a piecewise continuous. Remarks note, what remarks, these conditions are not necessary but only sufficient for existence of Fourier series. Note 2, f of x satisfies a Dirichlet condition of, and f of x is defined minus infinity comma plus infinity, then f of x has to be periodic of periodicity 2 pi for the existence of a Fourier series of period 2 pi. Note 3. If f of x satisfies a Dirichlet condition, if it is satisfying the Dirichlet condition and f of x is defined in the c comma c plus 2 pi, then f of x need not be periodic for the existence of Fourier series of period 2 pi. Note 4. If when I put if x is equal to a, it's a point of continuity of f of x, then the value of the Fourier series x equal to a is f of a. When x equal to a, the point is discontinuity. The value of Fourier series x is equal to a 1 by 2 f of a plus n plus f of a minus left limit and right limit. So in other words, specifying the particular value x equal to a in a Fourier series gives a series is constant that should equal f of a. However, if f of x is discontinuous at this value of x, then the series is converges to the value that is of way between the two possible function values. Now definition of Fourier series. Now moving to definition. If f of x is a periodic function with period 2 pi defined in a c comma c plus 2 pi and and the and the Dirichlet conditions, satisfying the Dirichlet condition, then f of x is expand the Fourier series. This is a Fourier series. Already we have to discuss. This is a continuous time period. F of x is equal to a naught by 2 plus summation n equal to 1 to infinity a n cos n x plus summation n is equal to 1 to infinity b n sin n x, where the Fourier coefficient are calculated using the Euler's formula like this: a naught, a n, b n. You have to find a naught is equal to 1 by pi integral over c to c plus 2 pi f of x dx. A n is 1 by pi integral c to c plus 2 pi f of x cos n x dx. B n is equal to 1 by pi integral c to c plus 2 pi f of x sin n x dx. This is a standard integral. A naught a n or a constant e power b a x sin bx dx e power a x by a square plus b square a sin x bx minus b cos x bx, and e power ax cosine bx formula e power ax by a square plus b square a cos bx plus a cos bx a cos bx plus b sin bx. So this is a from standard integral formula. We have to using the problem. Again, I am telling you integral e power ax sin bx dx. Integral e power ax sin bx dx equal to e power ax by a square plus b square a sin bx minus b cos bx, and integral e power ax cosine bx dx equal to e power ax a square plus b square a cos bx b sin bx e power ax cosine bx dx value you can directly apply e power ax by a square plus b square a cos bx plus b sin bx. Most important formula, Bernoulli's formula. We have to, with the help of the Bernoulli's formula, we have to solving the Fourier series problem an and bn. So this is a Bernoulli generalized formula integration by parts. Parts integral u of du dvx equal to u v1 u dash v2 u double dash v3 minus u triple dash v4 plus so on. Trigonometric results sign in by the most important, very important to know about that result. Sin n pi equal to 0, cos n pi equal to minus 1 power n, cos 0 value will become 1, sin 0 value will become 0. So this is very important. Sin n pi means 0, n is an integer, cos n pi is minus 1 power n if n is also integer. Now we moving the problem based on 0, comma 2 pi. The find the Fourier series expansion f of x square 0 less than x less than 2 pi, hence deduce that. So in here they are given the function and then deduction part also given. What is the deduction part? Pi square by 6 is equal to 1 by 1 upon 1 square plus 1 upon 2 square plus 1 upon 3 square plus 1 upon 4 square, etc. And second subdivision, pi square by 12 is equal to 1 upon 1 square minus 1 upon 2 square plus 1 upon 3 square minus 1 upon 4 square. And third subdivision, you can add these two, you have to getting this. Pi square by 8 equal to 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square. We have to discuss one by one. Discuss one by one. Now we have start solution. First you have to write the given. What is given? F of x is equal to x square 0 less than x less than 2 pi. F of x can be expanded the Fourier series of the form f of x. First you have to write the formula. That one you have to take it as equation number 1. Formula is, what is Fourier series formula? A naught by 2 plus summation n is equal to 1 to infinity an cos nx plus summation n is equal to 1 to infinity bn sin nx. The where the Fourier coefficient a naught, a n, b n all are Fourier coefficient. With the help of the Euler's formula, we have to solving the problem. To find the first a naught, a naught is equal to, know the formula, Euler's formula, apply here. 1 by pi integral 0 integral c to c plus 2 pi f of x dx. So what is the interval they given here? Uh, in question itself, the interval lies between 0 to 2 pi. So you have to change this c equal to 0. You have to 0 here, an upper limit you have to getting a 2 pi. The outside you have 1 by pi integral 0 to 2 pi f of x dx. What is given f of x? F of x is equal to x square. Now you can take integrate x to the power n formula, integral of x power n formula. Integral of x power n formula, integral of x power n formula, you know about that. This one, x to the power n plus 1 divided by n plus 1, x to the power n plus 1 divided by n plus 1. This formula we have to apply over here. F of x is equal to x square, n is equal to 2. We have to apply over there, n is equal to 2 plus 1, x to the power 2 plus 1 divided by 2 plus 1. So you have to getting x cube by 3 and interval 0 comma 2 pi. First we have to apply the upper limit minus of lower limit. So how to apply the upper limit? 1 by pi. Or first you have to apply upper limit. Upper limit, what upper limit is what? 2 pi. 2 pi the whole cube by 3 minus 0. Lower limit minus, you have to getting 0. So minus pi, this 2 pi is what? The 2 cube is what? 2 pi cube is what? 8 pi cube. 1 pi will get cancelled. Remaining, you have to getting this answer. Next, we have to find a n. An is equal to 1 by pi integral c to c plus 2 pi f of x cos nx dx. This type of this we have to apply over there, but we have to using the Bernoulli's formula. An is equal to 1 by pi integral 0 to 2 pi f of x cos nx dx. What is f of x in given? The x square. You have to substituting their f of x by x square cos nx dx. Now this type of the trigonometry and algebraic and trigonometric means you have to using a Bernoulli's formula. What is Bernoulli's formula? Integral uv dx uv1 minus u dash v2 plus u double dash v3 minus u triple dash v4 plus so on. So here is first you have to take highlight. So which one you have to consider as u, the algebraic term? So that is u equal to x square, d of v is equal to, that is v1 is equal to cos nx. You can take integration. You have to take differentiation. You x square you have to differentiate, u dash is equal to differentiate n into x to the power n minus 1 formula, x power n formula. So 2x 2x. So u double dash you have to getting 2. U triple dash will become constant. You have to be, differentiate. You will getting 0. Now v1 integral of cos nx dx. So integrate. You have to sin nx by n. V2 we can integral of v1 dx. V1 is what? Integral sin nx by n dx equal to minus sin nx. You have to integrate. You have to getting a minus cos nx by n square. b cube equal to integral minus cos nx by n square dx equal to minus, already have in a minus, cos you have to integrate positive sign, sin nx by n cube. Now we have to apply that uv1 Bernoulli's formula. You have to apply uv1 u dash v2 u double dash v3. You can apply over there. Then after, what you get, u is what, x square, and v1 is sin nx by n 2x is equal to minus cos u double dash or u dash equal to 2x minus cos nx by n square plus 2 u double dash equal u double dash in v3 cos nx by n what is this here? Here, gee, look at here. V3 equal to some minus sin nx by n cube. So you have to apply over there. Now after that, you have to apply the upper limit x square. Wherever x is occurring, you have to apply the upper limit 2 pi, and then low minus of lower limit you can apply. So finally, what you have to know about that is sine of 2 pi will become 0. Cos n 2 pi, you have a no answer, that is value will become a 1. Minus 4, this is also 0. See, this value will become 0. This is also will value will become 0, because sine 2 pi cos cos 2 n pi value, cos n pi, you know the answer. What is cos n pi? Cos n pi is equal to minus 1 power n, minus 1 power n. Cos 2 n pi is equal to cos of 2 n pi. So that is what, minus 1 power n is what here, square. So that is value will become 1. Cos 2 pi 2 n pi value will become 1. 1 already, minus 1 n square already have in a minus outside. So minus minus plus 1 by pi 4 pi into 1 by n square, and lower limit you apply, all the value will become 0. Lower limit apply, all the value will become 0. Then next, finally, you can simplify this one. What you pi will get cancelled. Finally, you get the answer an 4 by n square. And next, to move on bn, we have to find in bn is equal to 1 by pi integral c to c plus 2 pi f of x sin nx dx. Bn is equal to 1 by pi integral 0 to 2 pi f of x sin nx dx. F of x is equal to x square sin nx dx. So by using the Bernoulli's formula, integral uv dx uv1 minus u dash v2 plus u double dash v3 minus u triple dash v4. We have to apply using the Bernoulli, with the help of Bernoulli's formula we solve the problem. Again, you have to take u is equal to x square, u dash you can differentiate 2x, u double dash you have to take 2, v1 equal to what, you have to take sin nx. Sin nx you can integrate, you have to getting the minus cos nx by n. V2 is equal to minus cos nx by n. V1 you have to integrate. V2, you want to need a V2 answer, you integrating with respect to V1 with respect to dx. So which is equal to minus sin nx by n square. V3 equal to integral minus sin nx by n square dx. So sin nx you can differentiate. So you have to getting that you have minus cos nx by n cube, already minus of minus, you will to getting the plus sign, cos nx by n cube. V3 answer. Now you have to substituting u v1 u dash v2 u double dash v3 substituting. So you have to getting this like that, x square into minus cos nx by n minus 2x equal to minus sin nx by n square 2 into cos nx by n cube. Now you have to apply the upper limit minus lower limit. Wherever x is occurring, you have to apply the upper limit of minus of lower limit. You can first apply the upper limit 4 pi square minus cos of 2n x now. So you have to you have to apply 2 pi in by n. 4 pi already know about that, sign of a 2 pi value will become 0, and then cos of 2n pi value will become 1. This answer and this answer you have to getting value will become 1. This answer is 1, this answer is 1, this value will become 0, and then finally a lower limit also, this is also 0, this is also 0. Then finally last one, 2 times of cos n of 0 divided by n cube. 2 times of cos 0 value will become 1, already you know that. So now you have to substituting over there and simplifying this. The first term will first term will become, you have to getting a 1. So you have to take it as a minus 4 pi square n square, 4 pi square n is 4 pi square by n, sorry, plus 2 by n cube. Wherever where it occurring 2 by n cube, here this one, last one, first one in upper limit, in first one you have to getting minus 4. What is this? What are you getting this one? Minus 4 pi square by n, and this one is what, 2n cube minus of 2 by n cube, which is equal to minus 4 pi n. So Bn answer will get minus 4 pi n. After you finding this, you have to substituting that 2, 3, 4 equation, a naught, a n, b n value, substituting in equation 1. Substituting in equation 2, 3, 4, we have to substituting in equation 1. 1 imply, you know the formula, f of x is equal to a naught by 2 plus summation n is equal to 1 to infinity a n cos nx plus summation n is equal to 1 to infinity b n sin nx. So a naught value already know that. What is a naught value already found? No, a naught is equal to 8 pi square by 3, and you have to substituting over there. So 8 pi square by 3, a n value 4 by n square, and b n value minus 4 by n. Now you have to simplify this. So what you get, 8 pi square by 3 into 2. So 4 by n square cos nx, as it is you have to write this, plus into minus will become minus. Outside you have minus summation 4 pi n by sin nx. So finally you have to getting the answer is 8 pi square by 6. If you want, now you have to simplify this. So you're getting the 2 pi square by 3 plus summation n is equal to 1 to infinity 4 n square cos nx minus summation n is equal to 1 to infinity 4 pi n sin nx. This is a for your final answer. But now they given the problem, in given problem they give with the help of this Fourier series, you can find the deduction part also. Deduction parts, what you have to take now, first put x is equal to 0, there's a point is discontinuity at the end point. In the above Fourier series, how to write, the point will become discontinuity. Now you have to take this formula, f of 0 plus f of 2 pi divided by 2, which is equal to, and the Fourier series of final one, now final value you have to substituting there, take it here. Then next you have to substituting a f of value, now f of x value will become x square. F of 0 you want to find f of x is equal to what, x square. You substituting x is equal to 0, 0 square is 0. F of x equal to 0, you have to substitute, you have to 0 equal to 0, 0 square is equal to 0. F of 2 pi, what you have to get answer, which is equal to 4 pi square, 4 pi square, 4 pi square. So then after that you have to simplify this, you have to getting that 4 by 3 pi square summation n is equal to 1 to infinity 4 by n square 1 minus summation n is equal to 1 to infinity 4 pi n sin n of 0 will value will become 0, cos 0 value will become 1, sin 0 value x value you have to substituting both the side, RHS, and that is a Fourier series expansion. You have to substituting the x value and final answer, and LHS you have to take it as a f of 0 plus f of 2 pi, because this is x is equal to 0 is discontinuity. Discontinuity, now you have to take that midpoint, the point f of 0 plus f of 2 pi by 2, which is equal to, we have to substituting over the f of x value, you have to getting that answer. Then finally you have to take this 2 pi square, you have to simplify this 2 pi square. This is 4 pi square by 3 summation n is equal to 1 to infinity 4 by n square. Now we have to simplify this. This one, this equal to other side will come from this side. You have to getting a minus 2 pi square minus 4 pi square by 3. Summation n is equal to 1 to infinity 4 by n square. And finally, you can simplify this everything. You have to get an LCM. You have to take it as 6 pi square 6 pi square minus 4 pi square. Why 6 pi square now? 2 threes are you have to get in 6 pi square minus 4 pi square by 3 upon 3. LCM you have to take overall cross multiple you have to getting this, and then after that 2 pi square by 3 fours this 2 will 4, this 4 and 2 will get cancelled. 2 table 4 will going on 2 times. So finally after getting the pi square by 6 summation n is equal to 1 to infinity 1 by n square. You can expand the series. What you get pi square by 6 1 by 1 square plus 1 by 2 square plus 1 by 3 square plus 1 by 4 square plus so on. This is the first deduction part answer. And now move on the second deduction part. What is the second deduction part? You have to put x is equal to pi. When I put x is equal to pi, that is a continuity of the above Fourier series. When I put x is equal to pi, f of x is equal to pi square continuity. Now we want to use f of 0 plus f for 0 2 pi by 2. We directly apply x is equal to pi. F of x is what? You know that already given in a question. F of x is equal to x is f of x is equal to x square. This is a given in your question. So that make use f of x value. That is you have to substituting the pi value over there. X by pi you have to x square now. Pi square you have to getting. Then this is a Fourier series final answer. Then finally you have to getting a pi square. This will come from this side. Then after that summation n is equal to 4 upon n square cos n pi. Already you know about cos n pi. Cos n pi value will become minus 1 power n. So you can simplify this one. What you get minus 3. You can take that LCM. You can take the cross multiplications of 3 pi square minus 4 pi square by 3. That is simplify you out to getting a minus pi square upon 3, which is equal to sum, which is equal minus pi square upon 3, which is equal to summation. So you have to getting that same one as it is, you have to written here. Minus pi square by 3, which is equal to summation n is equal to 1 to infinity 4 by n square minus 1 upon 1 power n. Then after that you have to getting this. Finally you have to getting the 3, that 4 will become come from this side. So what you get minus pi square uh, by upon 4 into 3. And similarly the series is what want to find the series. So summation n is equal to 1 to 1 by 1 upon n square minus 1 power n. We expand the series. You have to getting minus 1. When I put n is equal to 1, 1 upon 1 square plus 2. When I put n is equal to 2, minus 1 square will become 1 positive 1. So 1 upon plus 2 square. When I put n is equal to 3, so we have to getting a negative 1 upon minus 3 square. Here you have to getting the LHS minus pi square by 12. Then after that minus take it outside common. You are getting here a series will become alternative sign. The pi square by 12 you have to getting. And third one is deduction of third value. The x value is substituting x as 0 pi by 2 pi 2 pi. The interval you have to take x is equal to 0 to 2 pi. In between pi by 2 pi here, so will not given by the deduction. Let us add above two equation and the above deduction you have to getting. Add the above equation. What is the pi square by 6 series and pi square by 12 you can add. You have to getting the final answer pi square by 8. This is 2 times of So what you get, 1 square, 1 upon 1 square, this 2 1 upon 2 square minus 1 upon 2 square will get cancelled. 1 upon 3 square, 1 upon 3 square, 2 times of 1 upon 3, that why 2 will take it outside, and then 1 upon 4 square minus 1 upon 4 square, positive negative will get cancelled, and remaining term is what, 1 upon 5 square plus 1 upon 5 square. This is a 2 times of 1 upon 5 square. So finally, this two multiple of these two come from LHS. Now it will become to denominate a multiple of that value. The pi square into pi square, sorry, pi square by 8. The final answer is pi square by 8. The series is 1 upon 1 square plus the series you have to write written as it is. That's all about the first problem. Now move on that second problem. Second problem, a problem based on 0 comma 2 pi. Find the Fourier series expansion. This is a trigonometry. The given function is what? Trigonometric. F of x is equal to x sin x in 0 comma 2 pi. Solution. Since the interval 0 to 2 pi, we need to find the all three Fourier constant. What are the Fourier constant? A naught, A n, B n. So A naught value you know about that. The interval will become 0 comma 2 pi. 0 to 2 pi in 1 by pi integral 0 to 2 pi f of x dx. What is f of x value in given x and sin x? You can substitute here. You have to using a UV method. Already you know, or you can use a Bernoulli's method, whatever it is. So u is equal to x, dv is equal to v1 is equal to sin x. So you can differentiate u. You can differentiate one u dash equal to 1. Then here, and we have to differentiate what you get minus v1. You have to integrate, not differentiation. V1 is a integration, minus cos nx, again minus cos nx, second integration. You have to getting a v2 value minus sin nx. See here, u is equal to x and v1 is equal to sin x. Now u dash you have to differentiate, you will get 1. U double dash you have to differentiate, you have to getting 0. V1 you can take integrate, so you have to getting V1 is equal to minus cos nx, cos x minus cos x. V2 equal to integral of V1, integral of minus cos x dx, cos x, cos x dx. So you're getting that minus already, then cos you have to integrate, you have to getting a positive sin x, sin x. That formula you have to apply, u v1 minus u dash v u v1 u dash v2. You have to apply here. Then after that, then apply here. After that, you have to simplifying this one. You can apply the upper limit minus of the lower limit. Upper limit is what, wherever x is occurring, you can apply the upper limit. X is equal to 2 pi. You have to apply in lower limit. You have to apply then 0. So finally, you have to simplify this equation. So what you get, 1 by pi minus 2 pi. So minus 5 pi plus pi minus pi will get cancelled because of multiple of that value. So which is equal to minus 2. A naught is equal to minus 2. Next, you have to find an. An equal to what? 0 to 2 pi f of x cos nx dx. So f of x is what? X sin x cos nx dx. Again, we have to using sin a cos b formula. What is the sin a cos b formula? X of x is already will be there, 1 by 2 sin n plus 1 minus sin n minus 1. So n is provided n is not equal to 1. Now you have to simplify this. You can take this, separate the terms, one by one term you have to take integrate, 1 by 2 x into sin nx n plus 1 of x dx, integral 0 to pi by 2 pi 1 by 2 x into sine n minus 1 of dx. You can simplify this UV method or Bernoulli's formula. You can simplify how to getting this answer. X is equal to minus cos n plus 1 of x. An is equal to 1 by pi integral 0 to 2 pi f of x cos nx dx. An is equal to 1 by pi integral 0 to 2 pi x sin x cos nx dx. Now we have to apply a sin a cos b formula. 1 by 2 sin n plus 1 minus sine of n minus 1, provided n is not equal to 1. Then after that 1 by 2 you can apply that x into sine of n plus 1 of x dx. 1 by 2 x into sine of n minus 1 of x in dx. Now you have to take integrate UV method. So u dv minus v du, or otherwise uv1 minus u dash v2 you have to apply. Then you know about that answer. So what you have to getting the answer? See here, x. So sine n plus 1 you can different integrate. So you have to getting minus cos n plus 1 of x by n plus 1 minus of 1 sine of n plus 1 of x divided by n plus 1 of x. Then next another one is 1 minus of 1 by 2. So x into minus cos n minus 1 of x in n minus 1 plus minus 1 sine n minus 1 of x by n minus 1 the whole square. First apply the upper limit minus lower limit. So you have to getting this answer. You can simplify this equation. So 1 by 2 pi into 2 pi 1 upon n plus 1 minus 1 upon n minus 1. Finally, you can take the cross multiple, take it as you have to getting this a 2 pi 2 pi will get cancelled. The finally how to getting a 2 pi 2 by n square minus 1, provided n is not equal to pi. Sorry, provided n is not equal to 1. Now when I put n is equal to 1, a1 equal to 1 by pi integral 0 to pi x into sin x cos nx n is equal to 1 na cos 1x dx. So you have to getting the answer x into sin 2x. Again UV method Bernoulli's formula you apply. Then after that what you get x, you have to keep it as it is sin 2x. You can integrate minus cos 2x by 2, and u dash minus already in the Bernoulli's formula. So minus 1 cos you have minus will be occurring here. So you can integrating with respect to the cos 2x, you have to integrate sin 2x by 2 into 2, we getting 4. Again apply upper limit minus lower limit. We have to getting a1 is equal to minus 1 upon 2. Next bn is equal to 1 by pi integral 0 to pi f of x sin nx dx. 1 by pi integral 0 to pi x sin x sin nx dx. So one integral 1 by pi integral 0 to 2 pi x into sin a sin b formula. So cos a minus cos a plus b of x divided by 2 into dx, x into cos n minus 1 of x dx, and minus of x into cos n plus 1 of x dx. The 1 by 2 we have to take it outside common. Now again you have to apply the Bernoulli's formula, Bernoulli's rule formula you can apply. So x is as it is. The cos n minus 1 you have to integrate, you are getting the sine of n minus 1 of x by n minus 1 minus 1 cos n minus 1 of x by n minus 1 the whole square. And then next x again n plus 1 as it is, you can apply over there. After that you have to apply that lower limit and the upper limit minus of the lower limit. So you will getting a bn value will become 0. So that's why we have to finding a b1 answer. N is equal to 1 substitute. So you have to getting the sin x you have to written as 1 minus cos 2x by 2. 1 minus cos 2x by 2. So x is equal integral 1 0 to 2 pi x in of 1 by 2 minus cos 2x by 2. So x upon 1, 2 and x upon cos 2x by 2. The 2 we have to take it outside common. Then finally how to apply 1 by 2 pi x square by 2, and then x into sine 2x by 2 minus 1 minus of cos 2x by 4, 0 to pi. Upper limit you have to apply, then after finally you have to getting answer will become pi. Then finally you have to substituting the answer, ends a Fourier series a naught by 2 a1 cos x plus an cos nx summation an cos nx b1 sin x plus summation n is equal to 2 to infinity bn sin nx. You have to apply there. You have to getting the finally x sin x, f of x value is x sin x minus 1 upon 2 cos x plus summation n is equal to 2 to infinity 2 upon n square minus 1 cos nx plus pi of sin x. This is the final answer, f of x answer. That's all about the second problem. Part 1 is completed. We have to discuss in next class. Thank you.